In today's video, we will be talking about refactoring reducer logic using functional decomposition and reducer composition. It may be helpful to see examples of what the different types of subreducer function looks like and how they fit together. So let us look at a demonstration of how a large single reducer function can be refactored into a composition of several smaller functions. So this is how our initial reducer looks like. The initial state has a visibility filter of show all and a to-dos. Next it has the app reducer. First case is set visibility filter, which returns object assign state visibility filter assigned to action.filter. Second case is add to do. Here we are going to return to-dos which is assigned to state.todos.concat id text and completed to false. So this is going to concat the properties. The third case is toggle to do, where we are going to return the object.assign, and then in our state we are going to assign the to-dos to state.todos.map, and we are going to check if the to-do id is not equals to the action id, then we will return the to-do, or else we will change the completed property to the opposite of the to-do.completed. We also have an edit to-do case. So here we are going to check for, again we are going to match if the id is same, then we will return the to do, or else we will assign it to action.text. And lastly we have the default case which returns state. The function is fairly short but already becomes overly complex. So we are dealing with two different areas of concern: filtering versus managing our list of to-dos. The nesting is making the update logic harder to read, and it is not exactly clear what is going on everywhere. So the first thing that we are going to do is extracting utility functions. A good first step might be to break out a utility function to return a new object with updated fields. There's also a repeated pattern with trying to update a specific item in an array that we could extract to a function. So for that, now we will add function update object. We are passing old object and new values. Here encapsulate the idea of passing a new object as the first parameter to object.assign to ensure we correctly copy data instead of mutating. So here we will return object.assign old object, comma, new values. Next we are going to add another function update items in array, passing the array item ID, update item callback, and then const updated items assigned to array dot map, and we are going to map the items based if item.id is not equals to item ID. So we will just return the item. Since we only want to update one item, preserve all others as they are now. Now we will use the provided callback to create an updated item. So const updated item, update item callback with item as the argument, and return updated item. And after this also we will return the updated items. Now we are just going to change a few things inside our app reducer. So here we are going to return instead of object assign, we will just write updated object, taking this state as a parameter. And next is the visibility filter assigned to action.filter. In all other cases also we are going to do the same. So we will remove this and we will just refer to update object, not updated object, update object. That reducer the duplication and made things a bit easier to read. So after doing this, we will see that it is easier to read these files instead of object.assign, and we have seen in the previous video that object.assign is not a very good method to be used here. So update object, next we can split each specific case into its own function. So the second thing that we are going to do is extracting case reducers. So here if we add a few functions like function set visibility filter and pass state and action. Here we will add a const new to do state dot to do's dot concat and whatever we are doing inside this concat, we are just copying this and we will paste it there. So we are just removing the code from here and pasting it so that the later on it becomes less complex. And inside here we are going to return update object with state and to do's assigned to new to do's. So this is the same thing that we have here. We have just removed it and set it to this is not set visibility, this is add to do. So this is add to do's, and for set visibility we will write a new function. So function set visibility filter state and action, and here we will just return update object with state and visibility filter set to action dot filter. So whatever we have inside the reducer, all these cases we are writing separate functions for them, and we will reduce the code inside the app reducer. Last is toggle to do. Again state and action as the parameter, const new to do's assigned to update items in array state dot to do's action dot id, and then to do is assigned to return update object to do, and the completed is set to the opposite of the to do dot completed. So this is the same logic which we are removing from here and we are putting it here. And after this we will return update object state to do's assigned to new to do's. Now we will add edit to do. So function edit to do state and action const new to do's update item in array state dot to do's action dot id. So then again we are passing it to, here we are returning update object with the argument to do text assigned to action dot text. And again update object is going to return. So now we do not need all this piece of code. We will just remove this, and inside return we will just say set visibility filter and pass the state and action. Similarly for add to do's again we will just remove all of these and we will just add to do with the same argument state and action. Next for this also we will remove and we will add toggle to do with state and action. Last is edit to do, edit to do with state and action. So now it's very clear what is happening in each case. We will also see some patterns emerging. The third thing which today we are going to do is separating data handling by domain. Our app reducer is still aware of all the different cases for our application. So let us try splitting things up so that the filter logic and the to do logic are separated. So in the set visibility, we do not we don't care about the previous state. So what is the logic of returning the previous state or something like that? So we're just going to return action.filter. No need to call update filter and anything else. We will just return action filter. We are going to add a function visibility reducer. This will take visibility state which is assigned to show all, that is the initial state, and action as the argument, and then we will add a switch statement with action.type and we will remove the set visibility case from here and we will paste it here. And the default case, default is return visibility state. Here it is going to take visibility state and action as the argument. So here what we have done that we have created a different reducer. And for all of these we will create, instead of app reducer, now we will name it to do reducer. That was a different function and this is a different function. This is all related to do and that was related to the visibility. So we removed that and we are going to add a new to do's reducer. So we will name it to do's reducer. We'll create a new reducer and then we will add that. So function to do's reducer setting to do's state to an empty array and action. And we will just remove all of this and we will paste it inside to do's reducer. Now instead of state we will call the to do state. Last also we will add the to do state. Now there is nothing like state. Whatever is related to the to do, we have to do's state only. So we will add all of that. So to do state dot concat, and again here also we will just change all of these. We will change it to do's state. Now for the app reducer, we still have the initial state and action. Here we will add a return statement where we are going to return to do's assigned to do's reducer with state dot to do's comma action And next, visibility filter assigned to visibility reducer with state dot visibility filter and action. So now the code is much cleaner and easier to understand. Notice that because the two slice of state reducers are now getting only their own part of the whole state as argument, they no longer need to return complex nested object and are now simpler as a result. The last thing we will be seeing today is reducing boilerplate. So we are almost done. Since many of us don't like switch statements, so it is very common to use a function that creates a lookup table for action types to case functions. So we will use the create reducer function for describing in reducing boilerplate. So now we will not require the update object function. So this is omitted. We can clear this. We don't require these. We do not require update array items also. So these two are omitted. Now we are going to create a function. We will also remove the set visibility filter. We do not require this. So function create reducer with initial state and handler. Return function reducer state assigned to initial state and action. If handlers dot has own property, checking for action dot type, so return handlers action dot type and state comma action, or else we are going to return state. Now set visibility is also omitted, and we are also going to omit the add to do, toggle to do, and edit to do. So we will also omit all these three. And for the visibility reducer, we will change this to const visibility reducer and assign it to create reducer passing show all and set visibility filter to set visibility filter. This is a very simple method. We have already used this many times. Rest remains the same. So the code has reduced by so much. We don't even need the add to do, remove to do. So we don't need all of this. This also we're just going to switch to const to do reducer assigned to create reducer, and we are just going to remove all this and just assign add to do to add to do and add to do. Similarly, toggle to do will be assigned to toggle to do. The comma, edit to do, and we will close the bracket. Here we will have a comma. Now last we have combining reducers by slice. Combining reducers by slice. As our last step, we can now use Redux's inbuilt combine reducer utility to handle the slice of state logic for our top level app reducer. So for that, in our app reducer, we will assign it to combine reducer and this is const here the visibility filter is set to visibility reducer and to do's this is assigned to do's reducer. We now have examples of several kinds of split up reducer functions, helper utilities like update object and create reducer, handlers for specific cases like set visibility filter and add to do, and slice of state handlers like visibility reducer and to do's reducer. We also can see the app reducer, that is an example of the root reducer. We have used root reducer a lot of times. Although the final result in this example is noticeably longer than the original version, This is primarily due to the extraction of utility functions, the addition of comments, and some deliberate verbosity for the sake of clarity. But this is a better way to code, and this is how we write understandable code. Looking at each function individually, the amount of responsibility is now smaller and the intent is hopefully clear. Also, in real application, these functions would probably then be split into separate files such as reducerutilities.js, visibilityreducers.js, todoreducer.js, and rootreducer.js. So that was it about today. I hope you understood refactoring reducer logic using functional decomposition and reducer composition. So that's it for today. I'll see you in the next video.